Hello, 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 dear ngVikings, dear Angular Vikings. My name is Maxim Salnikov, and it's my pleasure to host our first ngVikings meetup. I speak on behalf of Angular Vikings crew. We are super keen on communicating with you, keeping in touch with you between our big yearly events, and we promise right after it becomes possible and safe for all of us to gather all together in person, offline, offline, on-site, again, we will do this. Which country, which time, which date, just stay updated. Just looking at this intro video, I miss this gatherings so much. I miss ngVikings conference so much. But thanks to online delivery, we are now not just Nordic Angular conference, but we are worldwide conference. And during ngVikings 2020, May this year, we gathered 3,500 attendees from literally around the world. What is ngVikings meetups? As I told, we decided to keep our connection live between ngVikings and all our participants and attendees. So why not to meet, for example, monthly for smaller events, like same Angular Viking spirit, same deep technical discussions, but in a shorter time. And this is our maybe pilot episode when we collected really great technical program for you. But before I introduce our dear speakers for today, let me say a couple of words about our today's sponsor, which is Microsoft. And as a front-end developers, we often ask ourselves where to host our Angular application or React application or Svelte application or our completely custom application. The answer is Azure Static Web Apps. This is relatively new service from Azure Cloud where you can deploy your front-end application without too much hassle. Literally, you just point to the GitHub repo and that's it. The engine will do build, deploy, and after all, you'll receive your front-end app running on the globally distributed hosting. You'll have completely full workflow of CI/CD. Furthermore, you will receive great helpers for authentication and routing, two things we often use in our front-end applications, plus tons of other cool things like staging environments, like custom domain, and great support of serverless APIs. And of course, it's not only about Angular. It supports all the major frameworks, or you can configure to support your completely custom setup. It's very flexible, very powerful. I really encourage you to try this. aka.ms/static web apps. You will spend maximum 10 minutes to have your Angular application in the cloud on the global Azure infrastructure. Okay, then let me invite to our virtual stage our dear speakers. But before we do this, I kindly ask you to write in the comments, where are you watching us from? We don't have any chance to understand geography until you explicitly tell us. So please write the comment on YouTube Live, which country, which city, town, maybe which Angular community are you watching us from. And we today stream to multiple locations. It's Angular Vikings YouTube channel, it's ng Copenhagen channel, it's Angular Oslo channel, and even Twitch. Great, I see folks from Copenhagen, Israel, Netherlands, India, states, Italy, Berlin, Rio de Janeiro. Wow, amazing, folks! We are global event. Now, time has come to bring our dear technical speakers. Hello, Michael. Hello, Jan, Nicholas. How are you today?
Thank you, Maxim. It's very introduction. No, it's very special introduction there. It's good to be here, and wasn't able to write in the comment where I'm from. I'm from Sweden, but I am in Oslo.
Okay. Yeah, Nicholas, how about you?
I'm pretty fine. I'm very excited to be here today, and I'm right now in Kansas City, even though I'm usually living in Germany.
Wow. Even our speakers are globally distributed. I myself sit in Oslo, Norway. And it's obvious because I run Angular Oslo Meetup and I co-organize ngVikings conference. Okay, folks, I see that we are more than 100 folks online who is watching us. So no pressure.
No.
And we have a couple of minutes before the start. So let me explain the logistics a bit. So this is online event, and we decided to keep our sessions quite short, so like 30 minutes, maybe not the shortest time ever, but still we'll try to time frame ourselves. Session number 1, session number 2, and then we will have a panel. And panel, I really want to base it on your questions, dear attendees. This is why we have the comments on YouTube Live open. So please, during the session, write your technical questions to our speakers, and for the panel, we'll pick some of them, and for as long time as time allows, we'll go through your questions. And then let's start. And the first speaker is Michael Oates from a company called Soprasteria, but he will introduce himself. And then let me Michael, could you share your screen? And then Nicholas, see you in 30 minutes.
Sharing my screen.
Yes, let's try this.
We're clicking a little bit on the buttons here. Let's see.
Okay, I see this. Okay. So maybe just before you start, a couple of words about you, and then the stage is completely yours.
Thank you very, very much. So I'll be speaking about Angular or Blazor. And as you sit, I'm from Soprasteria. And yes, I will be introducing myself. And it's going to come in form of 3 stories, which all kind of binds this together, why I'm here, why Blazor, and how this material, which I'm going to present, came together. So I am long-time developer, been working on C# and .NET since it was introduced some 20 years ago, and seen a lot of things, but never really done front-end development since the framework of Angular and React came out. I was doing other things. But let's put that into pieces here, because this all started in Oslo, actually. 2017, the creator of Blazor, Steve Sanders, held a presentation on NDC where he had done an experiment. He had heard about WebAssembly, and he thought, can I make .NET run on WebAssembly? And he built it together using razors, and basically what we have the picture here, he presented in NDC in 2017. And he asked the audience, is this interesting? Would you like to run .NET in the browser? Now, 2020, in the lockdown, which happened in Oslo around March and April, I was home and my son was home too. So suddenly I was not working and I had a lot of time. And I felt, okay, now I'm just going to want to call myself a full stack developer. I'm going to learn a proper framework for that. And I'm sorry, friends, I chose React. What happened is I learned it. I got somewhat proficient at it, but it was a challenge because I had all the things I knew about .NET and C# and I wanted to reuse that, but I couldn't. And the thing that happened to me at that time was that I wasn't aware of Blazor. I wasn't aware of that presentation. But in June, I got the presentation. I learned about Blazor. And I was like, wow, this is really for me. And I got involved. I really become known as the internal expert in my company. And when the company asked me, hey, can you hold a presentation for employees that are interested? I started looking around the world on who's the best one on this. And I found a meetup in Central Maryland held by Lee Richardson, who done amazing work on first building a nice Blazor application, which isn't trivial, and also putting together a presentation. And I asked him, can I use this work in presenting Blazor? And he said yes. So that's what's going to happen. So that's me, that's Blazor, and that's the material we're going to talk about today.
Awesome, Michael. The stage is yours, so I disappear. Rock on.
Yeah, we will be rocking on. Thank you very much. Now, let's start with the application, because this application is going to come back in various pieces when I start talking about Blazor and then compare it to Angular. It's an application which is a game. Ability to type and not be eaten by shark. It has two modes, single player and multiplayer. And as my son doesn't really like sharks, I added the ability to choose other kinds of icons. Let's go for lion. Here we start the game. The lions pop up from the left, and if you're not quick enough in typing, whoops, something happened. Then they will eat you. Mark, toes. I see a space is not a good letter to type here. Let's do it again. Tour. This game is entirely written in Blazor. And for the backend part, that is a server which is used for when you have multiplayer. Single player entirely runs on the browser, and you could have a static page delivering it, similar to what Maxim just presented before. So now we've got the introduction in place. Let's move into the other parts of the presentation. I'm going to talk about what Blazor is. Let's hide this thing here. That's just in the way. That's better. I'm going to talk about what Blazor is. We're going to have a short demo where we will jump into VS Code. The big major part of this presentation, the shootout, and at the end, the summary. And move in here. Blazor. I'm a little bit of a history buff, so I like to look at things from the point of view of history to kind of understand what it is and where it comes from, where it's heading. And this timeline here puts Angular and Blazor in comparison, where Blazor started happening, as I mentioned, in 2017. It's not on this timeline because I just wanted to mention that because it's also specific. And in 2019, Microsoft released the first version, which was the server part of Blazor. And then the interesting part we're going to speak about now, Blazor WebAssembly, came earlier this year. And as you can see, Blazor WebAssembly wasn't available when I started playing around with React. And right now in November, the final release version of Blazor has arrived, Blazor as part of .NET 5. But it's a very short story compared to Angular, who's been around since 2012. And is currently in version 10 with the significant change which happened with Angular 2. There's another interesting part of this timeline, which is earlier than even 2012, and that's 2007. For those who remember, around 2007, there was this fight on, okay, how are we going to develop for the browser? And Microsoft said, Silverlight, that's the way to do it. And it had some reasonable following. But 2007, two things happened. HTML5 was announced and iPhone was released by Apple. And we know what happened since then. Silverlight is dead. And Microsoft has learned some things, which I'm going to talk about, because WebAssembly is an open standard from the same consortium as HTML5. More about that shortly. But first, let's walk into the difference between server-side and client-side when it comes to Blazor. Here's server-side, basically a simple sequence diagram on how things work. We all are familiar with the DOM, which contains what we see in the browser. And the server-side, everything is on the server. All the logic and all the state is stored on the server. So if you have 300 concurrent users on your site, then there are 300 instances of the tree in the server. That's sent to the UI thread, which is a simple JavaScript application, which then updates the DOM. If an event happens, like a keyboard or a mouse, then that's sent back. And the server looks at it and determines the difference, which is then updated to the DOM. All this comes together with SignalR, which is Microsoft's version of WebSocket. So it runs pretty well and fast, but it's not very exciting. It becomes exciting when we go into client side. Notice it's the same, basically the same diagram. It's just that everything now runs on the browser. C#, the .NET runs in the browser, and the DOM gets updated, event gets handled, everything in the browser. Let's compare that to Angular and server-side and client-side. What you can see here is that there are pros and cons for server-side and client-side. But contrast to Angular, Angular's got it all. It's a safe choice. It's check on everything, including this one, because it's not relevant for Angular. API size is the .NET Framework API size, where on the server side, you get everything. If you want to write to the console, do so. While on the client side, that's not an option. There is no console to write to. I'm now talking about not the browser console, but the server-side console. There are two kinds then on Blazor, Blazor Server and Blazor WebAssembly. WebAssembly, as I mentioned, is an open standard, but let's talk more about what that is. So it's the W3C consortium that came out with it, and they did that in 2013, don't quote me, I think it was something like that. And the important part here is that it's widely adopted. Every browser out there which is modern, which is everything except Internet Explorer, has it. And it's not a plugin that the user needs to install, it's just there. And this includes browsers running on every mobile device. So the support is just out there. And when it comes to programming languages, a lot of programming languages have decided that, yes, we compile to WebAssembly. C#, C, Go, and Rust as examples. But what is it, WebAssembly? Well, at its core, it's a binary instruction format for a stack-based virtual machine. Okay, what does that mean? Well, let's move to the next slides and I'll explain. Let's compare to JavaScript. Because if we want to run JavaScript in the browser, we need to send the JavaScript file to the browser. And there it gets parsed, it gets compiled. Now we have bytecode, which goes into the just-in-time compiler, which is really optimized to running this really quickly. And that then becomes native code, and we get the experience that the user gets. Let's contrast that to WebAssembly. WebAssembly, the file here can be any language which has a compiler. C#, Rust, or such. So let's assume it's a Rust file. It goes to the Rust compiler. That could be on the server, or it could be on your developer machine. And we get a WASM file, which is a binary format, pretty much bytecode. That is sent across the pipe and directly into the just-in-time compiler, and then it becomes native code and an experience for the user. So that's a little bit of the differences between the two. Another difference is that JavaScript is code that we write similar to other kinds of code, like the ones to the left here, which is C. WebAssembly is more like assembly code, which also the example here it illustrates. You recognize some assembly. It's similar to it. What we have here is a simple C function, which searches through a null terminated string and finds a specific character if it's there, or returns 0, -1 if it isn't. And it uses pointers and all these things that we are used to in the world of C. And to the right is the same thing implemented in a big loop, returning either the position or -1. I strongly recommend Jeremy Leikner's article for those who are interested in this. He goes with this example, but also talks about a lot of other things in terms of Blazor and WebAssembly. But it's not sent like that, the WebAssembly. It is binary. And this is what you can see here in the example here. all this stuff here is binary, and that's how it's sent across the pipe. And specifically what this file is, it's the .NET runtime WASM file. That's I'm doing an example here. And you can see all the other DLL files, which is part of .NET when you have an application, the different assemblies that you need. So here's TypeSharp, the game, and here are various things which Microsoft is providing. What's really interesting and what Steve Sanders did, which really opens a lot of possibilities here, is that he built a runtime which can run any of these DLLs which exist open the .NET ecosystem, as long as they're .NET Standard 2.0. And these DLLs can then run inside the browser. We don't need to do anything special with those DLLs. They just be able to run. It's this WASM file, which was before .NET WASM, but this diagram is a little bit older. So in the first instances, it was based upon Mono. That makes that happen. And that's the only part which is actually then compiled to WASM. And to make this all interesting, make it a full-fledged front-end experience, we have JavaScript interrupt with the standard stuff that the framework uses, but also the stuff that you can then use in your specific app. I'll show some examples. Combine that with everything which is available in a modern browser with HTML5 and such. And that's the runtime which allows you to create really exciting things using Blazor or any other web assembly language. So what's the benefits here? Well, first we have the subjective benefit, and I came with my stories, and I'm really true to this benefit. I can focus on the language I like and be a full stack developer. So for me, this is strong. I can say, hello, the language I love. I'm going to use it wherever I want to, in the browser and in the server. More objective benefits is that it's much faster. We're talking about near native. If you have an application run in WebAssembly and same application run locally, the user won't experience much difference when they start it and when they get to experience it. It's fast. In addition, compared to JavaScript, WebAssembly is a much more wider subset of instructions, which will allow for much more interesting things coming to happen now in the future, as a server can send a WebAssembly code to the browser, it gets run there. I think we're just on the start what's going to happen here in this world. WebAssembly clearly is the future for many things. Blazor is Microsoft's implementation using WebAssembly. It's just kind of start what's going to happen here, but it's a very exciting start, especially for the ones that already live in the world of .NET and this thing here. Let's have a look at its features. But before I do, let's talk about the name. Razor is a known language in the world of Microsoft. It's been around for a while, which is used for creating dynamic web experiences. We're basically putting code inside a static HTML, which this example here illustrates. We have various things with combining HTML and code. We've got data binding. This is one-way data binding. I'll show examples of two-way data binding shortly. We've got routing, simple kind. There is more advanced if one needs. As I mentioned, we can then import the .NET framework wherever we need. We can just say using, and we got it running in the code, running in the browser. And then very, very useful, dependency injection is a first-class thing in this language. And it's used for a lot of things. In this specific example here, logging. Components is also part of Blazor. And in this example here, there's a component that has an event, which is then mapped to a method which handles the event. I'll show you a little bit more components when we get into the demo. Interrupt I mentioned. Specifically for the TypeSharp demo or the TypeSharp game, the keyboard events are not supported by Blazor at this time. So one needs to go into JavaScript and get that event and then get it back to C#. And this is how it's done. And it uses dependency injection to do so. It's quite elegant. When it comes the other way, you're in C#, you want something to happen in JavaScript. this is the way to do it. It's just an example. There's nothing in Type Sharp that needs to do that at this time. Blazor has also the feature of being able to create really nifty layouts with templates and such and all this world. It's really cool. I haven't personally used it that much. I don't have that much to say about it. But if you're interested, there's this Pluralsight course which gives you an introduction on how to do that. NuGet, though, I know a lot about that. I've been using it all the time. As a .NET developer, we were really happy when NuGet arrived. It really changed the way you do code and reuse code. And the ability to take a NuGet package and run it inside the browser. And if you have a problem, whatever it may be, looking at NuGet to see, has somebody experienced the same, maybe built something I can reuse? Maybe it be to show markup or to handle some complicated JSON. It's really good feature that be able to reuse NuGet inside of Blazor. Okay, I've talked about features of Blazors. We've done that part. Let's move into the demo. And I'm going to demo inside of, let's see, VS Code. And let's start first with the structure of this application. It's basically built in 4 parts. We've got the client, which is a WebAssembly, a Blazor client. We've got the server, also part of Blazor. When you create a Blazor application, you can decide if you should have a server component or not. And then the shared part, which is interesting because here's code which is, you write it once and it runs both on the server and the client. You don't have to, when you're interacting between the server and client, you don't have to define your model twice. You define it once. Here's what it is. And it's very nifty. I'll talk a little bit more about that shortly with the player DTO model. And then obviously tests, which run on things which mainly are in the shared assembly. Interesting part is the client. So let's have a look here. For those who've done web development for a long time, this is nothing new. There is an index HTML. This is where everything starts when you run the app in the browser. And this is the magical line here, which loads WebAssembly. And this then will take over and replace this page with something rendered within WebAssembly. And that page is written in Razor. So let's have a look at pages here. And we go into the index Razor. This is the first page where we have the option of either doing single player or multiplayer. And using components to build that structure. So in the multiplayer, let's go into single player. Let's see now, that's this on select game menu components. Also defined in Razor and pretty much the same structure. And here you can see that I'm injecting the context of the game. So that's how this is structured. And then behind things, you have the code. So in this space here, there's this file here. There's the code behind the index file, which at compile time is put together into something that runs together. So that is the structure, and that's the very short demo. We're holding it to half an hour. So I'm going to move on to the shootout. So imagine here in the shootout that we have Angular on one side and we have Blazor on the other. And they've got their guns loaded and there are 10 bullets. Let's fire them away and see what happens. We'll start with view typing. View typing is the ability to help us as a developer to stay within the type that's been defined. And being a backend developer and worked with the solutions around Visual Studio and Visual Studio Code, I'm very used to having a lot of support. But let's give it some context first. This is a form defined in Blazor, and it is a two-way binding here with a name combined to the variable called temp name. And there's also a validation message combined to this. This is essentially this part here, which is the multiplayer game where we want to know what's your name. In Visual Studio, if you type incorrectly here, Intelligence Sense will instantly tell you that, nah, this is not going to compile, and if I can't compile it, it's not going to run. So this is red. And in addition, when you point that, you write that dot there, it will give you a drop-down list of available options. I remember being a Java developer some 20 years ago. You were just looking at the documentation all the time, trying to figure out, okay, what can I do with this class? You don't do that in the world of .NET nowadays, and it's really, really nice. Implementing the same component in Angular, you would be something like this, where we have the player name here in the HTML part, and the player name here in the code part. If there's a mistyping of somebody like that, there will be a runtime error, something like this. So this is the Blazor win. It's just much more friendly for the developer in this case. Let's look at the second bullet, which is CSS isolation. Here it shows that Angular's been around for a while, because you can isolate your CSS to one component, and you can work with the different kinds of CSS framework, and it's just elegant. It just works. It allows you to build big applications without getting in the headache of having that master CSS file that's supposed to contain everything without conflicts. Blazor, for a couple of months ago, had nothing of the sort, and in the end of October they got some support for CSS isolation, but this is an Angular win. Third bullet, validation, specifically user validation. Let's move into that thing I just talked about before, the same situation of writing a name. And let's have a look here at the marks here, which is saying to Blazor that I want to validate, and if there is a result which is not okay, put the summary here. But where does the actual rules come from? What is valid? Well, for those who looked at that DTO that I showed, you saw that there were some markers on it. And specifically here it says, what is valid? It needs to be a name, that's required. And the name can only be 50 characters, because that's the only thing we can handle within this game. There's only space for that. And when you're talking with the user, don't say name, say player name, with the ability to put different languages here. And Blazor will connect that all together, and if the user doesn't write it or write it too long, then there will be an error message. And also a friendly error message to tell him what it's about. Angular is different. There isn't that clear distinction between model and code. You put it all together. And this is an example here with password entry, where you have to enter it twice and they have to be the same. It works, it's quite powerful, but it's not as elegant. So I'm going to give this a Blazor ++ question mark, because it all works in Angular, but it's not as elegant. But that's not really clear for a win. Let's move on to tooling. In tooling, Angular's winning this one, I gotta say. We have the ngGenerate component, which is a really good experience when you're creating a new component. You get everything you need, you get started, you get running. It's all really well. In the world of Blazor, as a developer, you many times stay within the IDE, and the IDE is supposed to help you in various ways. Blazor is really new, so the previous months before it got stable, this was not really a pleasant experience many times. And if we contrast that to what we have in Angular, with the live development server that really pushes changes immediately, so the turnaround time as for development is really short, a nice experience. Adding a last thing, which is just going to put the nail on this thing, which is in Blazor, if something happens if you write code wrongly within the Razor file, you get into the generated file, which looks like this, and you're supposed to figure out what happened. It's ugly. As a programmer, it is not a good experience. So when it comes to tooling, Angular is just more mature by far, which brings into general maturity. I showed you this timeline. And that's part of maturity. Angular's been around for 10 years, but more importantly is the community. If you're doing something new in Blazor or Angular, and you don't really know how to do it, you can Google. In Angular, you most likely will find somebody who's done it, and there will be articles explaining how to do it and such. And very likely, there will be somebody who's made a package with code you can reuse. Blazor, not so much. And I can say this from personal experience. Many times I will have to figure it out myself because there aren't very good things. So when it comes to maturity, this is an Angular win at this time. Let's move on to language. And language are a little bit subjective, and I will focus on that a little bit. It's a lot subjective. And what this comic here illustrates is that on the internet, you can find any opinion. You can find opinions that you like and you concur with, and you can find opinion that you get really mad at. So for me and Richard, who is similar to me, would say that it's strange that C# is only number 10 in the Stack Overflow list of most loved and dreaded and wanted, most loved languages, because that's the list we're looking at here. Why is C# 10? C#, that's so great. Has so many things, it's so elegant, and it just continues evolving. My personal opinion. And as you can see, JavaScript is just below, and TypeScript is here as 3. And WebAssembly, well, I don't think anybody's actually coding in WebAssembly, as you saw in the previous example. But let's leave that subjective side and be a little bit more objective, and let's compare code. This is Angular code for providing the data for showing paged content. This is the key line here where we show the result as a page. This is asynchronous, so we need to have subscribe, and we need to have a finish callback to make this all happen. But also there might be errors, so we need to handle that in this way here. And all this comes together, it works. But compare that to C#, where there's try, catch, finally. This is what we're doing. If there's an error, we'll catch it, we'll do it here. And at the end, always independently what happens, finish the callback with an invoke. And this is synchronous with this await keyword here. It's just so much more elegant, so much easier to read. And remember, when it comes with code, code is written once and read many. So we focus on reading parts. Having said that, Blazor wins, or specifically C# wins. Debugging. That is a world of itself, and it is strongly connected to the tooling and the IDE. And in .NET world, we're used to all exceptions being able to be caught by the IDE, so we can easily figure out what's going on. And in this case here, we're fooling the compiler to compile this so that there's a 5 divided by 0, which is a runtime exception. And we run that, and we get bam. It's not pretty. Of course, we wouldn't do this specifically, but it's not hard when you do serious programming to get into a world where something will break and the debugging experience isn't really that good. You'll get into here and you'll have to figure out, if you're lucky, you can find the line. If you're more normal, you'll really have to do some debugging to figure out what's going on. Angular is just more stable when it comes to this. It doesn't put you into the world of mystery and debugging. Let's move into testability. We like test-driven development. I remember the world before testable development and the world after. It's just one of those things that makes a huge difference. And in Blazor, testable development is part of it. You put your code in shared and you put a lot of tests on it, and you can be certain that it works. And it uses a nice architecture where you put your business code in shared, and all the other code, which you usually don't need to do some testing on, is not there, so you don't have to do testing. Angular's got a lot of stuff related to that. Testing is all built in, so this doesn't have a clear winner. Let's make it a draw. Interop. And this is not the interop between Blazor and JavaScript, more the interop between the different languages and all the code bases out there which we can use. The story here is pretty much this: that Blazor likes NuGet, it's easy, we do it. Angular likes npm, it's easy, we do it a lot. Blazor can use npm and it can do interop with JavaScript. And Angular and NuGet and doing assembly, and it doesn't work at all. So this looks like a Blazor win, but actually it's not like that, because, oops, I'm going in the wrong direction. Oops. What's going on? Because in actuality, it's like this. There's no reason for an Angular developer to start using things in NuGet. Everything you could possibly need is an npm. But in Blazor, it's so new that there's a lot of things which it's not really built yet, not available in the community. So you'll have to go to npm to get it. And there's a lot of boilerplate code to make that happen. And if you're building something big, you'll be spending a lot of time doing boilerplates. So this, in this case, is an Angular win. It's just nicer. It's just easier. Code sharing. And I'm going to be specifically watching at the code sharing within your application. And in Blazor, as I mentioned, there's that shared assembly where you put all that code which you're going to use in both the client and the server. And in this specific case here with this game, the game engine is either run in the client or the server, depending if the user chooses to go single player or multiplayer. Same code shared right there in runtime. It's beautiful. And I think it's going to make it available for a lot of code bases out there with a lot of .NET code. It's going to be fairly easy to create an experience in the client, but still having experience running on the server. It's brilliant. It's a win for Blazor. Okay, that was the shootout. So do you remember how many won for each side? Well, actually, looking at the summary, it's not really relevant in terms of numbers. Because what we can see here is that if you're running something or writing something which is mission critical, you're on a tight deadline. It needs to be out soon, talking weeks or months. And that is going to use JavaScript libraries. Then by all means, use Angular. It's the solution to go. Or Vue or React, which are similar things. If you are .NET oriented, which is the NuGet dependency part, if you have a lot of sharing between server and client-side code, you maybe have a big .NET code base, and it doesn't need to work right now. It needs to work sometime in 2021. Or in this case of, it's a hobby, just want to play. Then by all means, start using Blazor. It's ideal right now for the companies which have a lot of .NET developers and wants to build something for internal usage. So this is the summary result of it, that it depends on your situation, which app is going to be built in which language. I personally feel that Blazor is a growing thing. And if I run this speech in a year from now, I'm going to say different things. As I mentioned in the beginning, this was Lee Richardson's material. He did a tremendous good presentation, and I've adopted some of the things. I've added a little bit to TypeShark, but the acknowledgement should go to him. With that, I'm done. So what do I do now, Maxim? Stop sharing, I guess?
Yes. Thanks, Michael. It was really inspiring presentation. I bet you convinced lots of folks to try Blazor. And by the way, we rarely had less than 150 online watchers during your session. So I think we found. Yeah,
excellent. That reminds me of something. This speech doesn't really tell you how to develop in Blazor. So stay tuned to to afterwards, and I'll send you some links to those who are interested on actually how to do the programming. This part is to be aware of making the choice, and then if you do the choice, there are lots of resources how to program in Blazor. I'll make those available.
Awesome. We already have some questions in our chat, but we'll take them during the panel right after our next session. So, Michael, I say goodbye just for 30 minutes to you.
See you later.
And I bring our next speaker to the stage, Jan Niklas.
Hi.
Ready to rock?
Absolutely. Let me share my screen and then we are ready to go. So for sure, right now that just started a construction work on the outside. I hope it's not too annoying. There's literally nothing I can do about it. I assume everyone can see my slide. Not that you can react, but Maxime can react. So
yes, we see your slides perfectly well.
Amazing.
And yeah, then the stage is yours. Start with just super brief introduction.
Good call. Very good call. Okay, brief introduction about me. My name is Jan Niklas Wortmann. I already mentioned it. I'm usually living in Germany. Right now I'm at my partner's place in Kansas City. We spent some lovely days in Aruba before because America's weird apparently. But today, some more words about me. Well, key facts, consultant for Evora IT, RxJS core member, and Angular GDE. I think that's a good introduction so far. Okay, let's talk about a little bit of testing. And today I want to introduce the concept of contract testing in particular. With this talk, contractually secure your Angular applications. And this should work. There we go. I at least faced, after multiple releases, the fact that I built this nice shiny front end and everything seemed to work great, but apparently the backend and their API changed, and therefore, even though we built this and we released it in the last minute and everyone was super happy, it's broken and we have to fix this as soon as possible. This is frustrating, annoying, and unnecessary. So what I'm saying here is pretty much one thing that could prevent this is integration testing, right? So spin up a whole environment, test your entire application, thought through with all the services available and everything. But this is super tedious and it just sucks, right? So imagine you're having like this fancy cloud architecture with several load balancers and AWS or Azure is handling everything for you. But spinning up such a whole environment just for testing purposes is tedious, expensive, and also a lot of work to get up a pipeline that is doing that and everything. And even if you have something like that set up, there's a reason out there that there's tools like Protect Your Flake, for example, that's just there to run flaky end-to-end tests. Again, like, I'm not blaming Protractor or this tool or whatever or any kind of end-to-end testing, but this just sounds insane. Like, okay, let's rerun fail tests because they're just flaky. And even though you have set up everything like that, end-to-end tests will just increase your build pipeline. Increase in terms of size and length. And this is not ideal from my perspective, right? But I want to introduce you to a different concept that does not have all these drawbacks, a new testing approach in general. And the testing approach comes with PACT, which is a framework implementing consumer-driven contract testing. I already introduced myself, so I will just skip this slide. What is consumer-driven contract testing? The best way to describe consumer-driven contract testing is by taking a look at each part of it. And I want to start with contract testing first. So this just means that you have some kind of contract that specifies your API interaction. So this contract clearly defines, okay, I want to have this request, and if I get this request to that URL with this and that body, those headers, etc., then I'm going to expect this response with that header, etc., etc., etc. So clearly define on a very granular level what is the behavior of this API. This is written down in a contract. And as long as consumer and provider use the same kind of contract, we can ensure that both of those parties can work in an integrated way. They don't have to run an integration to a very late point of time in the development process. It just has to ensure that both of them tests are happening with the same contract. On the other hand, we have consumer-driven. Consumer-driven means usually, at least where I worked so far, most of the time it's a backend team. There is some kind of backend team, and that defines the API. And then the front-end team comes, maybe needs some changes because things are weird. Stuff like that happens all the time. Consumer-driven now means instead that the backend, the provider of an API, comes here and defines the API, it's a consumer that says, okay, it would be good for us if we would have an API that behaves like this and that. Because in the end, the consumer has to fulfill some kind of business requirements with these APIs. I want to mention here, this definitely does not mean that the consumer dictates the API and just comes here and say like, okay, this is how the API has to look like, and I'm not accepting anything else, right? That's not how software development works. Software development is all about trade-offs, and this should be an open discussion, but we will see in the end how Pact implements this consumer-driven part, as it's very elegant. And that's what consumer-driven contract testing is about. So a consumer-driven, from the point of the consumer view, defined contract that is used for testing the consumer and the provider of an API. I already used a lot of terms now to explain what consumer-driven contract testing is. Let's take a step back and take a quick look at those terms. And consumers, it's quite easy, but I just want everyone to get on the same page. So consumer is the one that uses an API. That does not necessarily need to be a front-end application or a client application. Technically, for example, if you're in a backend for front-end architecture, your middleware might be a consumer of some kind of API as well. Later on, we will see how to integrate consumer-driven contract testing in Pact. Therefore, it's given that our Angular application is the consumer of an API. Provider, on the other hand, is the one that provides the API so that the consumer can pick it up, use it for its purposes. Usually, this is some kind of backend technology providing some kind of REST API, GraphQL, or any kind of message-based API. The last thing that I want to clear here is interaction. And an interaction is exactly the contract defining one HTTP call, one interaction between consumer and provider. So an interaction consists out of the request payload with all its headers, etc., and the response payload with all its headers, status codes, etc., etc. Okay, so much about consumer-driven contract testing. Let's talk about Pact now. And I'm lazy. I think if you watch any other talks of me so far, we should have established this so far. But I looked up for a definition of Pact on the documentation. And there it's written, Pact is a code-first tool for testing HTTP and message integrations using contract tests. I think we covered that already. So now we know that Pact is more of a testing tool providing consumer-driven contract testing. So like, just to give an example, Jasmine and Karma are tools to implement unit testing for Angular applications, for example. How does Pact now work? I'm a consultant. I have sophisticated graphics here. So let's take a quick look at this. Let's start on the consumer side this time. On the consumer side, we have a unit test written down. And within this unit test, we spin up a Pact mock provider. And we fill all our contracts in there so that the Pact mock provider can take a look at the specified requests and responses and act accordingly. Therefore, our consumer sends the request like it would in a normal business flow. It sends out an actual HTTP request. And the Pact mock provider now takes a look at this request. And if it matches the specification, then it will return the mocked response according to how it's specified. So I'm in this talk not talking too much about provider verification in general, but let's quickly take a look at the provider side as well, just to establish a common ground for how this whole process works. So on the provider side, it looks similar. Just the fact that now we're spinning up the whole server for our provider. So either backend, some kind of Spring Boot, whatever it is in the end. You just spin this up, and then you also run a packed mock consumer and fill this one with the contracts. This time, it's now pretty much inverted. Now our packed mock consumer simulates the consumer behavior. So it takes a look at the contracts, takes a particular look at the requests, sends out this request to the provider, and evaluates the returned response of the provider. If this response matches, we are good to go. This is how provider verification works on a high level. Okay, we talked a lot about concepts and everything. I know you want to see some code, so let's jump into how to use packed with Angular. So I already mentioned you have to write some kind of unit test, and in Angular application, it's quite common for unit testing either to use Karma or Jest. If you use Karma, due to its nature that it's natively running in the browser, you have to install certain packed node modules like Karma Packed and Packed Web. If you're running Jest tests, which are running in a node environment, you can just go with Packed Node. Therefore, also my personal recommendation here to use Jest for packed test. I'm in general not the biggest fan of Jest. It has its drawbacks like every technology, but for packed testing, I can highly recommend it just because it will make your overall setup a lot easier. Okay, let's take a look at code. And I made an excerpt of the Tour of Heroes pretty much. So usually when you have HTTP interaction in Angular applications, you wrap that in a service, or at least you should wrap that in a service. So, and here what we're doing is we are calling HTTP client get to perform a GET request to a certain URL, and we are expecting an array of heroes back. The auto-generated unit test by the Angular CLI would kind of look like that. So we are configuring our testing module, we are injecting hero service, and then we check for if the instantiation of the service worked out. That's all the auto-generated test does. What we now do for packed testing is that we are doing, in our configure testing module, we're importing HTTP client module. This is very important because usually you would import HTTP client testing module. But if you use HTTP client testing module, you would not perform real HTTP requests, which is normally the idea of unit tests. But in our packed test, we know that the provider will be available as we spin it up within our test execution. So we can, and we have to use HTTP client module here to perform real HTTP requests. Afterwards, we are instantiating a new packed element that you import from packed foundation, packed node. And you have to specify some kind of meta attributes. You have to say which consumer and provider is used. So consumers should be always the same within your Angular application. Provider might vary depending on your architecture. Port is the port that the mock server runs on. Depending on how you do environment configuration and stuff like that, it should be the same port, or you have some kind of special environment configuration, totally up to you. We are still simulating a web application. Therefore, we have to enable CORS for our packed mock provider, and packed itself comes in a versionized specification level. So the packed specification supports different features for its contract specification. As far as I'm concerned, packed is right now working on specification 4, but therefore level 3 is the latest and greatest, and we aim to go with the latest and greatest here. Afterwards, we're calling packed setup. Packed setup will then spin up the node server in the background so that we can communicate with them, perform actual HTTP requests. This returns a promise. I could wrap this with then, etc., but it's also fine to use async await here. Now we have our packed mock server, but we didn't in some way pass the contract to that. And how packed is implementing that for the JavaScript ecosystem is that within the unit test, you can now call packed add interaction, which will afterwards also generate the contract in a JSON format so that you can use it for further CI processes, etc. So packed interaction is now the specification so that you can create a contract and put this in your packed mock provider. And we have also a couple of meta attributes that we have to specify here. The first thing is state, which describes the provider state. You can also use this feature to say that certain tests have to run in a certain order and stuff like that. So it's the assumption under which state your provider is right now for your test. Upon receiving is really more just like a description saying what this contract, what this interaction is testing. With request now comes in and specifies the request itself. Therefore, you can specify the HTTP method, you can specify the path, you can specify headers, you can also, not with a GET request, but you can also specify a body. So if you imagine you had a post request that you're doing here, then you could add a body here. Lastly, we have the will respond with. And within will respond with, you specify the response behavior. Here we are saying, and this is a very easy example now, we are saying, okay, we get back a status code 200, and then for the body, we're expecting an empty array. Empty array would, for the consumer verification, would work probably well. For the provider verification, this would not work really well, as it's very unlikely that at any point of time, our backend service will always reply with an empty array. Imagine you have some kind of database. At some point of time, there will be values in your database which are going to be returned. And by default, packed is doing a very, very, very strict type checking on those types. So if there's anything in this array, if it's anything else than an empty array, this test will fail on the provider side. So what I specify in this contract now is that I'm too stupid to use my slides properly. What I'm specifying now in my body is so-called matchers. Pack comes with a matchers API, which you can consider kind of like regex. So you can say like, okay, I'm still expecting an array, but matches each like says, okay, I'm expecting an array with at least one item in it. And then in each like, you can specify the shape of each object in that array. Therefore, we used matches like, and matches like will behave like that it does a strict checking on the properties. So there has to be an ID and a name. And it does a strict check on the type of that, of the value. So the ID value has always to be of type number, and the name value has always to be of type string. I just did the S0 here to get some kind of IntelliSense feature so that I don't have to come up with the proper names on my own. And lastly, what we have to do is in an after each and after all block is I once called packed verify and packed finalize. Packed verify will fail if your packed verification, if either the consumer request or the response did not match at all. Finalize will then go and take the contract, the interaction itself, and creates a JSON file out of that. That's what I meant before. You can then take the JSON file and do some kind of CI process so that you can guarantee that the same JSON file is used for your provider verification. Okay, lastly, how does the test itself now look? So what we do is at least that's the way I usually test observables. I'm subscribing to that. And again, here we imported HTTP client module. So this performs a real HTTP request. And then I take a look at the hero object that is returned. In this case, because it's returned by the packed mock provider, it will be exactly one element, exactly like we specified it in the matcher. Afterwards, technically, it can. This is an asynchronous operation, so I'm calling done manually. Do notice this is a very easy example of how to do consumer verification with packed and Angular. Usually what you should aim for is that you're thinking in a more, you should think in an interaction-oriented level, but also consider it more like a process. So sometimes it also makes sense to test how your interaction works in a certain flow. If your application works under these conditions, if the provider behaves as specified. You can play around with the example I showed with the technologies listed here. So I have this demo repository where I have a Nest backend, an Angular client, and just tests. The provider verification tests for the Nest backend are still missing, but all of that is in a mono repository. So sharing the contracts between those two projects is fairly easy. But to make it more real life experience, I used Packflow, which is a cloud service provided by the Pact core team to host Pact files. So the provider verification test will come within the next days. So if you're interested in that part as well, stay tuned. I also developed a set of schematics to make testing with Angular and Pact a little bit easier. So if you want to play around with that, I would highly recommend using those schematics. And on top of that, if you have feature requests like saying, okay, I'm using this workflow, that would be super handy if this could be covered in this set of schematic. That would be great. Right now, we are supporting Karma and Jest as well. So there's barely any reason why you shouldn't be able to use ngX Pact if you want to do Pact testing. Okay, let's talk about some of the pros and cons, because in the beginning, I was a little bit bashing end-to-end tests maybe, or integration tests, which is not fair. It just sounds good, and it's a good introduction to this talk. But there's still benefits to all technologies like Pact in this example, but there are also drawbacks. The biggest benefit is that you have super fast feedback. Like it's literally just an HTTP call on the same domain. So it's like calling localhost. Like it's super fast. You're testing the integration of two systems in a very reliable way. There's barely any chance if you do proper contract testing that your provider and your consumer won't work together, right? A nice benefit is if you're working with separate teams that take care of those separate systems is that you make the development process a lot more independent. You can use for the more or less the entire development process just this contract specification and then deploy it, and it should be good to go. It's a little bit polemic, I know, but you see what I'm saying here. And particularly about the benefit about Pact is it is designed for CI and CD processes. So there's pretty much for more or less every language, any kind of language that you can imagine an integration with Pact. So I think most of the initial implementation with Pact happened in Ruby. There's a Java integration, there's Go, there's PHP, Node. I'm pretty sure there's something about C# and Scala, if I remember correctly. So there are a lot of languages supported. And the best thing is that the developers behind Pact had always CI and CD processes in mind. So there are great tools out there that support your particular CD processes so that you can develop and deploy more independently with relying to those contract tests. Let's talk about the drawbacks. So one of the things with Pact is it changes your development workflow, your development process, as you're more relying on those contracts. And changing the development process itself sounds easy, but depending on your team sizes and stuff like that, this is a tough decision to make, and it might put you out of your comfort zone. So this is definitely something to consider. And in terms of testing, it's just testing the API compatibility of two systems. This does not involve some kind of business processes and stuff like that. So this doesn't say your application itself is right, or it doesn't protect you from refactoring in general, like unit tests and stuff like that. So it's just one part of an overall testing strategy. You can't replace proper end-to-end tests with Pact, from my point of view. Another thing that might be a little bit tedious if you're working with huge object structures. So right now I'm in a project where we're working with SAP objects, which are like gigantic. It's ridiculous. And for some reason, they're all uppercase, which also doesn't make sense, but I'm not here to bash SAP. What I'm saying is, if you have huge object structures and you want to define those in a contract in the interaction, this becomes very tedious, as you have to develop regex patterns to make pattern matching for all of this. And it's tough. And the last thing to mention, but this is also to consider that Pact is entirely open source. Documentation, as most open source projects, could technically be better, even though it needs to be considered that the documentation itself improved heavily within the last years when I started to use it for the first time. Okay, I already said Pact does change your testing strategy, and it's just a tiny part of that. Therefore, I stole a slide of one of the maintainers of Pact. But what you have here is usually you have the testing pyramid with 3 steps: unit test, integrated test, and end-to-end test. And now if you want to do contract testing, it's pretty much a layer in between which shrinks your end-to-end test. You still should do proper end-to-end test, but with Pact, because one huge part of end-to-end test is verifying that your systems work together, can be handled by contract testing in a more reliable way. This is more or less all I want to show in terms of Pact. If this was of interest for you, a couple of weeks back, I started to write a series of blog posts about consumer-driven contract testing with Pact for JavaScript developers. So I will cover a part about Angular or consumer verification with Angular. I will write a part about provider verification with Nest and stuff like that. So if this topic is was interesting for you, check out this blog post. There are a couple of more informations, and there will be a couple of more informations afterwards, as my time in such a presentation is very limited. And lastly, I really have to thank everyone who came to this talk, watched it, and particularly the amazing folks of ngVikings who provided this platform to do this talk. I highly appreciate it. Thank you very much.
Thank you very much, Jan Nicholas. Great talk. I never used Pact, but you convinced me to try this. I hope
win.
Yes, I'll succeed, and lots of our participants also will try this. Now, time for something interesting, which is speaker panel. We have lots of questions in our comments. So, Michael, welcome back to the discussion. Michael, you are currently on mute, just to let you know. And let's start with the question of Blazor. Maybe you had chance, Michael, to go through some of the comments we received. If not, let me pick some relevant ones. First, some folks say that they will use Blazor instead of Angular for their next project. So I think you gave them really good validation of their idea. Some folks say that they use both Angular and Blazor. And there is not actually a question, but sort of comment that Blazor documentation is really badly structured with mix of everything, server wasm on the same page. Then let me convert it to the question: what's your source of Blazor documentation? Maybe you can mention some resources, if not official, but maybe some interesting. Where do you get information?
I get the information you're using Google. And many times it's Microsoft, sometimes it's Stack Overflow. Very often it's GitHub, where you find code and you have a look at it and you find the solution. But it's also based upon the fact that I am a .NET developer, so a lot of information which you typically would have to find, I already know because I've been working for this for multiple years. So it's based upon the things that we already know as .NET developers. I feel that the comment is fair. If that was one of the bullets, I would give it to Angular, because Blazor was released 2 weeks ago. and the documentation is nowhere close to what you can find for Angular in any kind of, because in Angular there's so many different resources from different perspectives and depending on your needs. I will provide some links on the various things which are available on GitHub. There's a lot of code available that we can check out, either reuse or be inspired. It's a good place to start to see how to code in Blazor.
Mm-hmm. Cool. Yeah, from my side, I'll promise to at least tweet all the links Michael and Jan Nicholas will share with us. So folks, just let me put it on screen. Follow our Twitter, and you will receive all the materials. And also, I will ask our dear speakers to share their slides if that's possible. So stay tuned, folks. On Twitter, you will have everything, and of course, the announcements of our next events. Okay, let's take the next question. Michael, can you comment on the roadmap for Blazor, and maybe let's take it in the context, just as a follow-up of this question, how to make sure that Blazor will not end, will not repeat the history of Silverlight.
Okay, yeah, Silverlight, that was a story. I mean, similar to the different versions of Windows that arrived at that time. Anyway, so Microsoft has a history, and in this case, one has to remember that it was a different world. 2007 is what I mentioned as my speech, because a very important year. We got the first smartphone, the iPhone, and we also got HTML5, the standard. And that changed so many things. But before that, there were 3 companies competing for the rich internet application. There was the Java alternative, there was the Silverlight alternative, and there was the one that everybody was using, which was Flash, Adobe. After that, Apple basically took over. And in 2010, Steve Jobs said, no, I don't want to run Flash on my iPhone. Okay, he used different words, but that's essentially what he said. And that whole market died. Where these 3 companies, that they had their own proprietary solution of code running virtually around the browser. You had to install it, you had to upgrade it. It was cumbersome to compare to what we have today. And additionally, in the browser for the mobile, it was using a lot of the battery. And that was the reason why it didn't work on the mobile. So that whole thing died. And strong reason was the HTML5, because that did the same thing. And it was an open standard, no company behind it. And so that was adopted. And Angular was built on HTML5, React was built on HTML5, and all the things that we now take for granted as developers and as web users is there. But it wasn't. No, so what's different here? Well, WebAssembly is not proprietary. It's the same consortium, the W3C, which is behind it. And when you have companies like Apple, Google, Intel, and Mozilla that all contributed on significant parts of WebAssembly. And of course, Microsoft has also contributed. So the question is not about Silverlight per se. The question is about WebAssembly. What's going to happen with WebAssembly in the future? Well, you've got these really big companies and all these really big platforms. Intel was actually part of WebAssembly too. So we know that Google and Apple are supporting it. So with all the web phones, it's going to be running there. We know that Intel and Microsoft is supporting it, and also Red Hat, by the way. So we know that it's going to be running well on Linux and Windows. So WebAssembly is going to be everywhere as an open standard. That is true. That we know in the technical industry. What the question is then, will Microsoft be able to position themselves as being the best one using WebAssembly? That I don't know. But it's not going to disappear the same way it did in 2010 when Steve Jobs said, poof, everything mobile is not going to work. So no worries. Blazor is here to stay. It's not Silverlight 2.
Great. We trust you, Michael. Next question is more technical, actually. What about multi-threading? Is it somehow supported on Blazor?
At this time, if I would do a bullet on that one, it's Angular Win. Because in Angular, you have good support for background threads, and you can do things in the browser behind the UI and thus give a better experience, more enhanced experience to the user. Currently, Blazor is a single thread, and you can do various things. There are articles about it to make things happen in the background, but compared to Angular, it's not as elegant and tedious. So a bullet on that one would be an Angular Win.
Cool.
Now, adding another sentence, Blazor right now is in version 1.0. Remember Angular 1.0, which is like, no, we don't want that.
It was not Angular, it was Angular JS.
I know. So I expect that Blazor 2, which is going to come to us next year with .NET 6, a year from now, it's going to lift things and just address some of the weaknesses that we can see today.
Yes. If we compare the maturity, of course, Angular is winning here with a huge advantage. By the way, folks, let's wake a bit up. So if you write on the chat, which is the latest stable version of Angular currently, just to check your knowledge.
Yeah, I said that in my speech.
It was announced recently. Yes. So let's check your knowledge. Yes, we have winner, I believe. Yeah, folks. Of course, yes. It's version number. Not 10, folks. You are a version behind. Stable version is 11 now. Recently we celebrated.
Oh, okay. My bad. I'm sorry.
Okay, and I believe we have one more question about Blazor. It's about components. How do components talk to each other, especially those who are not parent-child, but like siblings?
Sibling components, how do they talk to each other? So that would be the shared code part, where the design suggestions that are there is that kinds of interaction, you'd go down to the shared code. You have your business rules, you have your state down there. And as I mentioned, that shared code could either run in the browser or could be running on a server if you have multiple browsers cooperating with some use case. So that's how it's recommended to do that. And it's also typically a very good way of doing it. You want to separate the presentation from your logic.
Yes. Yeah, by the way, in the comments, there is sort of battle of the versions, 11 versus 10. Yeah, folks, I'm not blaming at all that you still think that it's version 10. I only encourage you to check Angular 11, which is containing lots of interesting features. So hopefully the upgrade upgrade journey will be very smooth, at least from 10 to 11. Angular team does a great job on providing proper tools. And Angular 11. Jan Niklas, we have some questions to you. First, my question to all audience: what do you folks use for integration testing, if not Pact? Was left completely unanswered, so no other tools, frameworks mentioned. Maybe you could give us some overview. So if, for example, Pact doesn't exist, what could we use then to automate somehow, to simplify, to make better developer experience on integration testing?
So what I usually do, and it's maybe not the best approach, but it worked out fairly well, at least if you have proper end-to-end testing tools like Cypress. What I go for is for plenty of unit tests and really in isolation, and then plenty of end-to-end tests. So it's like it's definitely not a pyramid or like a triangle, if you compare it to the testing pyramid, but you get at least good insights if your component integrate well with each other. It's a lot more effort. So that's also to mention, if you do stuff like that, you should consider having proper test engineers on your team taking care of that. This is nothing that the developer on his own can manage properly from my point of view. One thing to consider for proper integrated tests is, though, since Angular 6, where we have provided in, you kind of have integration tests by default if you don't take care of that properly. And there's actually an open issue of that, because that behavior annoys me terribly. So I would appreciate everyone who's watching the stream who could go there and upvote it so that we can get rid of this behavior. So just to clarify this a little bit, technically, most of the cases you have when you use provided in, you use provided in root, and therefore every service will be provided in every testing module. And it's a real implementation, which is not the desired behavior for a normal unit test. So in the end, you kind of end up with integration tests there if you don't take care of that.
Fair enough, fair enough. Next question. In a world where Swagger specification could generate strongly typed services, is Pact still advisable?
So first of all, thanks a lot for the feedback, because I thought about adding a slide for Swagger to my presentation, and now I will definitely do that. In terms of Swagger, the thing is, and even though, let me start first of all, I'm not the biggest fan how Swagger generates the auto-generated code. This is a personal opinion. I like to have my code under control. I like the way that the Angular CLI is doing it. It's very minimalistic, and it's pretty much just a basic scratch that I don't want to deal with. In terms of HTTP interaction, this is a lot more code that has to be generated. And I personally prefer to do this on my own. And on top of that, the drawback, Swagger is actually just a documentation tool saying how your API, what types your API provides. It's not a documentation on a level how your API works in terms of authentication, in terms of how does it behave in an error scenario. Sometimes you want to retry HTTP because sometimes you want to cache some things and stuff like that. This is all not covered by Swagger. And either you have to provide layers on top of that for your auto-generated code, and then you have to know about RxJS a lot, which is possible. But it takes a lot of flexibility that I usually like. So I don't consider, so from my point of view, Swagger is more like a documentation tool that can provide good types. Pact is really a testing tool, verifying the behavior between consumer and provider. And there are actually tools out there that can generate contracts from Swagger files if you use that too. Again, I'm not the biggest fan of Swagger. I prefer Pact.
Mm-hmm. Got it. Can we test chained API calls with Pact?
Can we, sorry?
Test API calls which are chained.
Yes. So the thing is just that you have to consider then is that you have to add multiple interactions. So in the step where I call Pact add interaction, you would have to do this multiple times so that every HTTP call that is made within this flow in this chain is covered by the contract. But then you would just do pretty much the same as either, just for multiple interactions.
Yeah, cool. And so actually no more questions, but not a question, but kind of sharing another technical approach. Wojtek is talking in the comment about his approach. So from his perspective, we have unit tests on backend to test endpoints, and for frontend we generate API SDK from Swagger, which also generates TypeScript type guards. And if you don't like how Swagger editor generates the code, have a look on API client generator. That exact motivation of creating it. That we like Wojtek and his team didn't like the generated code. Would you like to elaborate on this, Jan Nicholas? Is it like similar?
So, it's definitely good to know. I will definitely check that out. As mentioned, I usually don't like the way Swagger generates code. If that's better. So just to give a reference, I saw once auto-generated Swagger code, which had numbers in the method name and the HTTP method. So it was like get heroes once and uppercase. And it was weird, and I really don't like that. I have to have my function names consistent. If this is done better there, I would highly appreciate that. But it still does not, and it cannot cover behavior of an API. This is something that you can't auto-generate by code. That's just not possible. So this part is still a little bit uncovered. And on the other hand, which is also uncovered by auto-generated Swagger code, is the interpretation of values. So even though something is auto-generated, for a consumer, a property just from a semantic value might be something different than the provider intended. This can be covered by processes that are established around that and proper documentation and stuff like that. But it's still not guaranteed just from auto-generated type. While on the other hand, consumer verification guarantees that.
Awesome. Yeah, I really love technical discussion we had today. Yes, it's the intention of events like this to not only teach but also learn. I'm a constant learner, and I think we explored Angular versus Blazor from multiple points of view. We explored Pact and its alternatives, and yeah, it's all in the name of great applications we create, and we want to have both great user experience and developer experience for ourselves. Before we wrap up, I have a special surprise for all our dear attendees, and I want to invite on the stage my dear colleague in Microsoft and my dear colleague in ngVikings conference and this meetup, Sherry. Welcome.
Yeah, sorry, Maxim. I was a really horrible co-host for you today.
No worries.
Yeah, I had the kind of other meetup running, and they overlapped as usual. And I still couldn't discover how I could clone myself. But yeah, that can be a topic for a hackathon later on, how to clone ourselves. But I partly listened to both talks. They were great, and all the discussion. And thank you, Maxim, that you encouraged we have ngVikings Meetup up and running again. And definitely we want to have this show going on. Of course, not today, but you let us know on Twitter to all of you that what you want to learn next. Definitely we will bring our speakers for you, because this is your show.
Yes. I consider this very first edition of ngVikings Meetup as very successful one, and thank you, dear speakers and dear participants. You were very active, and actually you did this show. So let's stay connected, and we really want to continue with these meetups. Meanwhile, we think about the next edition of ngVikings conference, online, on-site, offline. No idea yet which country, which date, but yeah, we'll definitely. There'll be no trade-off between safety and our wish to run this event. So stay tuned. This will be something really big and loud, and you will hear about this if you follow our Twitter. So this is pim. So I see that we still have more than 100 simultaneous watchers online, and I expect 100 more followers on Twitter today. Let's wrap up. Any final comments from you folks?
I would root for ngVikings at Iceland. Just mention that. I would highly appreciate it. So Iceland is very high on my bucket list anyway, and this way I have a good reason.
Yeah.
We'll definitely consider. I think definitely, yeah. And it's really, yeah. If you dream about post-COVID times when we can meet together,
Yes.
I think it's really interesting in terms of it's in the middle of between Europe and US,
True.
where we have many attendees. So yeah, great. Then, folks, have a great evening if you watch us online and you're from European time zone. And yep. Let's stay connected. Bye-bye.
Bye-bye.
Ciao.
Bye.